Damn, I'm young again. This is
No
lit.
limit to human potential, optimism, and our ability.
Is a huge aspect of the project. There are 17 observing modes with Webb, and each require very special treatment. And it's been a lot of effort, years of effort at the Institute within the instrument team to design the best possible data pipeline so that the community can actually use them as soon as they can. And so, as we show today, it works. And of course, there will be improvement, but that is a very fundamental aspect of the project, that yes, we have a beautiful telescope instrument that works, but also data pipeline.
Those pictures are beautiful.
Thank you all. I know we have a few more questions in the room here.
Look at the Webb pictures, y'all. You can see the stars so clearly.
Thank you, Marcia Smith with SpacePolicyOnline.com, and I think my question is probably to Eric, but I'd be interested in anybody's answer. And it's one of these philosophical questions again about where all this fits in our understanding of the universe. And so when you see all these galaxies that you didn't know were there, there are exoplanets everywhere.
Habitability question that it'll be used to ask.
Go ahead, Chris.
The image of the deep field, the near Canon image. I think, just as an excuse to show this, so this was one of the European contributions was towards the MIRI instrument, but just on the left here you have the deep field, including the MIRI wavelengths.
I always liked the wonders of the universe.
I think this is an area where kind of everyone's just looked at this and gone, what are we looking at, right? Like, and the whole community is just going to get stuck into this immediately, and there's just going to be a huge leap in what we can do, again, by having this huge wavelength coverage for the first time. And just by looking at these, kind of comparing them immediately, you can...
The first images of the Webb,
sure,
the telescope, that's in outer space,
it's just going to catalyze a whole chain
that
of lots of
I think it got X-ray vision.
I think it's been mentioned a couple of times.
We have in our own solar system, we have ocean worlds. Is that where most areas of habitability exist in the universe? We just don't know the answer to that, and I think Webb in this exoplanet research will be able to make leaps in that direction. We get a much better understanding of where we actually ought to look, whether it should look like the Earth or look like something else.
Other questions in the room? Anyone who... Here we go, do we have any? We've already asked. We have a couple over here. Oh, and what from some who maybe haven't asked one as well over here.
Hi, my name is Abdul Dramali. I'm with NASA Social. I'm an astrophotographer. That's way better than my work. My question, we briefly touched on dark energy in the previous question, but my question is more specific to dark matter. And given that we have no instruments that can directly interact with or measure dark matter, can we expect to learn anything new about the makeup of galaxies and other celestial objects?
The reason that those arcs are there, the reason that those twisty, those long, stretched out, distorted, taffy galaxies look like that is dark matter, right? It's the gravity of the cluster that's doing all the distortion, and almost all of that is due to dark matter, right? So of the mass energy budget of the universe, we understand 4%, right? The stuff that's the periodic table, the stuff like us, and the rest is dark energy, which we don't understand, and dark matter, which we don't understand. So, when you look at an image like this, you're right, we can't directly detect dark matter, right? It's confounding, but we see its impact, right? It's the dark matter that is doing the lensing in this field, right? So there's not enough mass from the stuff we're made of in there to do it. There's not enough stars. It's dark matter. So directly detecting it is something different. That's a laboratory experiment. But what we can do is see how it works and how it interacts. I'm getting pretty excited. So we can map out where the mass is in the cluster, and we can understand the mass distribution and how it relates to galaxies, which helps us understand where the dark matter is. And that's an indirect way to get at what the heck is going on with dark matter. But it's the most powerful tool we have astrophysically to do that, is this type of lensing experiment.
Dark matter also it's one of the big overarching questions we're hoping to answer with this telescope is really to learn more about the big picture of how galaxies change over time, right? You see the very distant galaxies in these images look totally different than the way nearby local galaxies look. And sort of putting together that picture of how galaxies change, really important. And we know that dark matter has key role in that? Because we know all the galaxies that we see are surrounded by this dark matter. Dark matter is sort of the scaffolding of the universe that galaxies process of galaxy evolution. We're going to be able to learn more about how dark matter works.
Thank you. And we have time for maybe one or two more questions here. And I know there are a couple over here.
Hello, I'm Joy. I'm a guest of NASA Social and host of Sunday Civics. It was said in the program earlier, and I know this from different missions, that there's a lot of science and invention that went into developing. And then also from missions and NASA work in general, there are a lot of things that transfer over from space and science to the regular world. And so can you talk a bit about, I know there's one thing so far that has transferred in terms of LASIK or something, but you know, what other things could we expect or look at that could come to the regular world, to regular people from NASA?
And so this might not be something that shows up, you know, in your optometrist's office or on your kitchen table, but a whole industry learned a new way to bond materials together, to glue composite structures together. And so a lot of invention we may not see directly here in the room, but it changes how industry works. And
I don't know why I was drawn to the web, but I like the web.
And the company that invented that. And I know folks at Northrop Grumman also had to invent some new processes in their own manufacturing of space vehicles. So that's a big part of this turning NASA research
that can do
into
all types
regular
of stuff.
industry
What are
products.
they figuring out there?
Thank you. And this is the last question that we have time for. So we can go ahead with one more.
This is so interesting. You see the stars so clearly. You see the galaxies, the dark matter. All of that stuff matters.
Is it on? Sorry.